Hey, what's up? I'm Sam, and today we're going to be looking at the fundamentals of test-driven development with string calculator Kata. Alright, welcome to string calculator Kata, and you might be wondering, what is a Kata? Kata is basically an exercise. We're practicing the technique of the test-driven development skills, so you can think of it as LeetCode or HackerRank, but instead of solving these algorithmic problems, we are going to practice the skills of test-driven development. So it's very easy once you get the hang of it. It takes a little bit of getting used to, but once you do it, having the skill in your tool belt is really important. And so basically, there's 3 laws or rules or whatever you want to call them, but it's red, green, refactor. So you write a failing test, you make that test pass, and after you get a couple of them going, you're going to refactor your code and make it pretty. That is all to say, make a decision and then do it. And that's basically all you're doing in test-driven development. You're making that decision up front, and then you're writing your code to implement that decision, whether it's a design decision, so on and so forth. And before we even jump into the code, hot take, I don't really think it matters if you write the test first or second. I think this is a good skill to have in your tool belt, and what's more important is the outcome or the type of code that is produced from thinking this way. And that is code that is decoupled and very easy to change, right? So if I have to write unit tests for this thing and I do that first, I'm going to make that code very easily testable. If it is a pain to test it, then I am doing something wrong. And that also means that probably my design is too cluttered, is too overdone. So I'm gonna keep things simple. I'm gonna move quickly. I'm gonna put one foot in front of the other. Everything else you hear about test-driven development maybe have some truth to it, but a lot of it is just noise. So once you know how to write this decoupled code well, it does not matter whether you write it first or second. What matters is the type of code that is produced. All right, that's my hot take, and I think we can jump into it now. All right, so this kata is, I got it from Roy Oshergrove. I hope I'm saying that name correctly, and I'll put a link in the description to that, and I also have the source down here in the README. So we're going to create a function. It's going to take in a string, and we are going to add those numbers. Complicated stuff here. So method can take up to 2 numbers separated by commas and will return the sum. For example, empty string or 1 or 2 as inputs. For an empty string, it will return 0. Okay, so I'm gonna pause there, and I think this gives us enough to start with. And yeah, these hints are really critical. And yeah, start with the simplest test case of an empty string and move on to 1 and 2 numbers. Yeah, that seems like a really easy thing to do. So I have just this basic test file here, already stubbed out. I wanted to make sure it works before I started this video. And yeah, so we can go ahead and get going with this. So add should. I like to frame my test this way because it makes it very explicit, like this function should do this, and it's behavior driven. So what should happen? It should return 0 when given an empty string. All right, so if I do expect add to equal 0. Okay, so I haven't even written the function yet. So I start with a test. This is red. Obviously it doesn't exist yet, but I have already started defining this interface. I know what this code needs to look like to give me this test case. So now that I'm here, I can start adding my function. And I'm gonna do it like this. Numbers. Okay, so what is the easiest thing I can do to make this test pass? I'm gonna hard code a 0. You might be thinking, Sam, that is really dumb. Why would you do that? And you're right, it is dumb, but we are on our first test and we are doing whatever we need to do to get moving. Oh boy. All right, so it's kind of read from that compilation error. We didn't have anything yet. And now we got our first test case passing. Nothing to refactor yet, but let's keep moving. So next one, if I have one number, I need to just return that number. I need to get like prettier up in this thing. Okay. So I'm just gonna copy this one and I'm gonna go down here. So what's the next case? So should return the number if given one number. And these probably aren't the greatest like test descriptions, but we can always change them later. So if I put a 1 here, it should return 1. And we know this is not going to work. We will run it anyways. All right, it failed. That's good. All right, red. All right, so we can say if numbers equals empty string, return 0. All right, so if our other case is just one number. Let's see, this is a string, so we need to all right, I think that should work. All right, so next case. So we're gonna add 1 and 2. And you and I both know that equals 3, but we are gonna prove that out. So return the sum of 2 numbers. We know that's gonna fail. I'm just gonna go ahead and run it anyways. It's good habit to, every time you do this, just keep running it. So do it, run it, do it, run it. So you get into the habit of just running your test all the time. And if your tests are slow, in this particular case, my tests are slow because I'm screen capping right now, but normally this is very quick. But if your tests are running slow, then you will be incentivized to make them faster, or you will be incentivized to not run them, which is bad. You want to run your tests a lot. Okay, we knew it was gonna fail. All right, so things are getting a little bit more complicated. So what do we need to do here? Well, we can split on the comma. So let's do that. We can say like, let sum equals 0 for I think we can do this const num of numbers split on the comma sum equals sum plus, don't forget cast here. It's not cast, I forgot what that's called, but all right, I think that should work. And again, like, you're not worried about making your code super pretty in the beginning. You're just worried about making it work. Once you have some tests in place, then you can refactor and make it pretty and start making other design decisions. But at first, you just want to go from like 0 to 1 as quickly as possible. That's why first case, we just hard coded 0. So you want to move very quickly. You want to keep your momentum up while you're doing this. Okay, everything passed. We're looking good. All right, now I think this is a good opportunity to refactor because this is getting kind of gross, and anytime I see lets, I'm looking to get rid of them. So, all right, what's our first move? So if I pass in an empty string, I don't think we actually need this anymore. Because if we start with 0 and then there's nothing to loop over, then we should just return 0. Sweet. Okay. All right. Let's see if we can. I think we can one line this. So I'm actually going to do that. So I think we can take this here and we can say numbers dot split dot reduce. All right, and then let's see. I just forget how to use reduce. Okay, and then okay, so we're gonna add them here. And then our default value is going to be 0. All right, let's see if that works. Boom. All right, we are still green. Everything's looking good. We refactored. Yeah, this is a subjective thing. You could also do it the way we had before. Might be a little bit more legible or readable. It's up to you and your team's coding standards. But looks good to me. Satisfied all the test cases in this simple one. So I'm gonna leave it there, and if you want to, you can keep working through this. I'll post a link to the repo in the description. And before we go, just a few things. You notice like I put the function in the test file. I like doing this like with new code because you're staying in the same file and I can just move quicker. And then when I'm done, I can do this. So like the refactoring tools in VS Code are really cool. And I can just move to a new file. Bam. Okay. So I started in the test file, then I just extract it out to a new file. And it will automatically do all the export and everything. And then we're good to go. All right, and yeah, one last thing. You might be thinking, yeah, test-driven development is great when you have a list of instructions telling you exactly what to do. But I can't do this with production code. And that, while that is true in some sense, I will make another video and we will go through some production code on a little side project I got an idea for and show you how to do it there. So in this example, you are learning the technique of doing this type of cycle of the red-green refactor cycle. When you're working in production code, you're more like making design decisions. So what should happen if this thing doesn't exist? Should it throw an error? Should I return undefined? So once you get into like actual production code, your test cases become more like behavior. How does this system behave? What should it do? What is it expected to do? So we will get there in a future video, but I wanted to lay the foundation here. And yeah, I'll leave it at that. Let me know what you think and talk to you next time.